Hi everyone, and welcome back to MongoDB TV Cloud Connect. We have a very exciting episode today. We'll be talking about smarter applications and how do you build them. You may have guessed that we'll be talking about machine learning and artificial intelligence, but we'll also touch upon some very important topics like reducing your operational, I'm losing the words here, innovating faster, scaling better, and reducing your operational overhead. I got it. And we have a very special guest today here. We have Delphin from Google joining us. Welcome, Delphin. How are you feeling today?
Hi, Mira. Thanks for having me. So my name is Delphin Barankanira. I am ISV Cloud Partner Engineer at Google, and I'm looking after EMEA. So nice to meeting you, and thanks for the invitation.
Sure, pleasure is all mine. Where are you joining us from today?
Yeah, I'm based in Paris. I work across EMEA. I'm based in Paris, France. Nice to see you all joining us today.
That's awesome. And if you are watching us on LinkedIn or YouTube, you can also share where you're joining from. I am joining from the Bulgarian seaside right now. It's the middle of the summer. I realize that some of you might be on vacation or at least working close to the beach today.
Yeah, this is the summer period. So, but we never stop learning. That's why we are here. So yeah, thanks for joining us today.
Awesome. There are some people joining from Philadelphia. That is Mike Lin, who is also on the stream today, but he'll be staying in the background. We have people from Tunisia, Serbia, awesome. Some neighbors. That's amazing. So Delphin, what is your work like working with partners and working with different organizations, guiding them through their digital transformation?
Yeah, thanks. This is a very, very good question. And actually, really, we are in an exciting moment, right? I think our work and as an IT specialist, it has never been so interesting. And actually, really, what we have seen is that over the last few years, especially during the pandemic, the need for digital transformation has accelerated. And we observe that companies, they need to innovate faster, better, and they're ready to be able to offer differentiated services. And this is true, for organization, wherever industry or vertical they are. And what really we see that really is a big challenge for them. There are four things that we see they are facing when they try actually to build, to transform the applications, even to build smart applications. I think number one challenge they face is the speed of innovation. And I think people, listening or watching us today, I think this really maybe something we may have been facing, right? So because the need for speed of innovation is really something important because organization is constantly, accelerating. They need to keep up in order, to stay competitive. That's number one. Number two, there is the need for scalable applications. This is not only about the software layer, but also for the infrastructure. Number three, that we're going to be talking about today, Mira, it's really how do we help them, reduce cost and improve efficiency by simplifying operations. Last but not least, how do we help them basically include intelligence into the applications? How do they leverage machine learning? How do they leverage generative AI within the applications? And this is everything that we're going to address today. Those four challenges are really the menu that we are going to address today with you guys.
Awesome. So let's talk about the first part, speed of innovation. Here at MongoDB, what this means for us is offering Atlas, because Atlas is an integrated platform. It has all the services that you might need when you're working with your data. You have full text search, you have data federation where you can fetch data from different sources. You have a bunch of APIs that you can use to get started quickly. And you have authorization and security. And this is what it means for us at MongoDB to be able to innovate faster. But from your experience, what does it mean at Google Cloud? Because I'm not gonna lie, Google Cloud is my favorite cloud platform, and I'm really excited to be talking to you today. And I always have a lot of fun using all the Google Cloud services. And I really think that they have been built with the customer in mind or the developer in mind. But what does it mean from your perspective to innovate faster, to enable your customers to build faster and better?
Yeah, Mira, this is very important. So for us, really speed of innovation is about simplifying the experience developer have with the platform. So it's really about all the different steps for building an application, from the design to the deployments to the operating the application when it is live. It's also about eliminating complexity. So it's about, making possible for developer to not worry about the infrastructure and to be able to focus on their applications and to be able, for example, to do a one-click automated infrastructure creation, and this through standardized blueprints. And we enable this at Google. So if you can see, for example, in the slide I'm sharing, you can see that Google Cloud is really offering really everything you need to be able to be successful in that sense. Google Cloud is really the most open cloud. We have innovated and created and put at open source different projects. For example, Kubernetes, right? TensorFlow for machine learning, and so forth. So we've been one of the most open cloud, which really helps developer, accelerate. They don't have to rebuild their code. They can just run the code. It's also the most advanced cloud in terms of AI. So Google has been living, I could say Google Cloud is AI native. So AI has been at the foundation of all the services that we are using. Moreover, what we also offering is that we are offering most reliable and performant infrastructure. So the same infrastructure that is powering your Gmail, your search, your YouTube is the same basic infrastructure, the same foundational infrastructure that we are offering to the organizations. So if it's able to handle billions of customers, of course it can support your customers. The last one, it's really about offering the best network. But we don't stop there. We believe that in order to speed the innovation, we need to meet the developers and architects and the organization where they are. Whether they need to be able, for example, whether they are using compute engine, so VMs, whether they are using Kubernetes, whether they are using functions, everything they need is there, so they don't have basically to lose time. They can accelerate, and we are able to meet them where they are. But this is the really key. This is foundational. This is how we help them, combining a most open cloud with the most basically all the service they need to be able to support their transition, to be able to build basically modern application and smart application. Today in the demo, you will see Cloud Run. Cloud Run is an amazing service. It combines the power of Kubernetes with the power of functions. So Cloud Run is really a container platform, but you don't have to provision the infrastructure. It can scale automatically from 1 to 1,000 containers. And this is, you don't have to, to monitor or to operate your infrastructure. As a developer, you can just focus on writing your code and developing faster. So this is how for example, we enable, and we're going to show you an example of an application in the demo later today. And what I want to add, Mira, is that it's not only about speed of innovation. Your application needs to scale. So from your point of view, how MongoDB helps organization build scalable applications?
Yeah, so if we were to move to our second point today and talk about scalability, from the MongoDB perspective, I can say that MongoDB has been built with the cloud in mind and scalability. So MongoDB offers horizontal scaling. Now, what is the difference between vertical and horizontal? With vertical, which is the traditional way of scaling a relational database, you just get a bigger machine, a machine that has more resources, more RAM, more CPU, more storage, and that is how you scale. With horizontal scaling or scaling out, on the other hand, you just add multiple nodes, multiple different machines, multiple servers, and you spread your data across them. That is how you scale. And the technique for doing that with MongoDB is called sharding. And this is not something that is specific for MongoDB Atlas. It is something that has been built into the very core of the database from the minute when it was conceived. And sharding allows you basically to scale to an unlimited number of machines and to scale to thousands of customers, thousands, like more than that. And sometimes I'm getting asked that question, like, is MongoDB now good for production? Because a lot of people have started using MongoDB 10 years ago and they started facing some issues and they left after that first impression. So I always say, like, we have more than 40,000 customers. MongoDB, even though it's a NoSQL database, it is quite production ready and it scales a lot better than traditional relational databases. And it has really been built with the cloud in mind, and we are living in the cloud first generation of computing right now. So this is definitely the database that you should be looking at if you're building a new system, or at least you should be considering using a document general purpose database such as MongoDB.
Yeah.
And I know this is true for Google Cloud as well. I mean, I have a little bit of the background of how Google Cloud was conceived, but I'm sure that Delphin can tell us more about how Google brought their own internal infrastructure that powers Google Search and Gmail to the general public.
Yeah, absolutely. When you are serving billions of users, you need to be able to have a scalable platform. And really, this is something that is native to Google Cloud. And actually, MongoDB running on top of Google Cloud kind of benefits from the scalability of the Google Cloud. So what a developer wants, we believe that they want to be able to build an application and be able to handle, for example, a huge spike of traffic. They want to be able to handle the Black Fridays. They want to be able to, to go home knowing that, their platform can scale and can handle the demand. At Google, we have a strong belief that one of the key benefits is to leverage serverless infrastructure. So serverless means that you don't have to manage the infrastructure. The infrastructure can scale and to be able to meet your demand. So Google Cloud, one of the key, value proposition or key differentiator for the audience listening to us or watching us today is really the fact that Google Cloud is a serverless cloud. So you can have an end-to-end architecture where every single service is a serverless service, which means that you don't have to manage the infrastructure, but also you only pay for what you use, which means that the resources are provisioned when you need them and they are released when you don't need them, which also helps you do some cost saving. So we have all different services from PubSub, for example, from PubSub to the Cloud Data Store to Cloud Function, Kubernetes, Cloud Storage. So all those services, basically, you don't have to spare time and really manage the infrastructure. So this is key for us. We believe that offering serverless infrastructure, it's uniquely differentiating Google Cloud for helping a developer achieve, the scalable application. But we don't stop there. So, together with MongoDB, we help, build those scalable applications. But this, move out to the third point that we want to discuss with you today. Once you have built how this scalable application, how this scalable platform help you build the simplified operations. So really, this is the third point we want to chat with you about, and I want Mira to share more how MongoDB help remove the challenges to the operational challenges from the operator of the IT infrastructure.
Yeah, so MongoDB Atlas is generally a highly managed platform. You don't have to care about security and availability and also maintaining consistency. I saw that we've got one of these questions as well in the comments, but there is more than that. So Atlas allows you to deploy your database in one of the three major cloud providers, but you can also spread it out across different zones and across different clouds. So you can have one zone in Europe in Google Cloud, you can have another zone in the US in another cloud provider, and you can have a third zone in Singapore in like the third major cloud provider if you want it. This is what it means to be multi-cloud, and you can create these multi-cloud deployments with just clicking a button in Atlas. And this allows you to spread out your data and have higher read access or more performant read access in different zones in different parts of the world. This also allows you to keep your data where you want it to be. So if you are operating in Germany, the German laws mandate that data of German customers should stay within the German borders, physically in data centers there. And this is again configurable by just clicking a button in Atlas. You can have the German data stay within Germany. So this is a kind of a managed platform benefits that you get when you're using Atlas. You also have managed backups. You have very comprehensive monitoring with performance advising, with a dashboard that has more than 100 metrics, real-time performance monitoring, and alerting that you can customize based on your needs. And you can run all that on Google Cloud. You can actually subscribe right from the Google Cloud Marketplace. If you're already a Google Cloud customer, this will allow you to have a unified bill both for your database and the other Google Cloud services that you're using. And we have a pretty good reference architecture that Delphin was just showing us here. This is, as you can see, MongoDB in the very center, and you can have a bunch of other Google Cloud services that you can integrate and run your applications on.
Yeah, absolutely. And really to add on top of Mira, really to be able to simplify operations, it's also to have enterprise features. So like you explained, the fact that you have you don't have to worry about the capacity management, the fact that the cloud natively scale, it's really a good value. But the other thing I would love to add on top of that, it's really simplified integrations. So we have worked together with MongoDB. We've been working to build templates, integration templates. So for example, in this architecture diagram, you have on one hand, you have the sources of the data. So Google Cloud, of course, you can support streaming and batch. But what is interesting is that you can have the compute integration with Cloud Run, what you see here, Cloud Run with MongoDB to run basically your application. But the benefits of that is that once your data is on MongoDB, you can integrate your data within a Google Cloud BigQuery and machine learning architecture over here, because we made it so simple for the organization to be able to stream or to batch data from MongoDB to BigQuery via very simple, pops up to MongoDB template, MongoDB to BigQuery change data captures. This is for streaming. And for batch integration templates, we have built basically BigQuery to MongoDB template. So you can really push the data very simply via click of button to push your data from BigQuery to MongoDB, and also from MongoDB to BigQuery. This is really something that is helping organization do more with their data, because then they can, for example, be able, if you are running an e-commerce website, once your data is in BigQuery, you can either implement BigQuery machine learning, you can integrate with Looker, for example, for BI, or you can run Vertex AI on top of that, basically, for example, to do some recommendation. And then these data can be pushed back on MongoDB and be exposed to the application, for example, to do recommendation for an e-commerce, or to do fraud detection, or to do any kind of business application. So this is really something that is critical, and we're going to chat about it in the next topic, actually, why we are there, right? So the next topic, like a transition, the last topic, it's really about how we help organization build smart application. And this is key, right? And before that, before we really jump into the smart application, I want to give an example of a customer that has been able to gain the three advantages that we mentioned. So one customer is Forbes. So many of you knows Forbes, which is basically a 100-year-old publisher, very known for its business journalism. They have migrated their CMS from on-prem to MongoDB and Google Cloud. They've been basically running the application with several Kubernetes clusters, and they have basically been running several microservices. And what they have done is that this migration, this new fully-fledged, cloud-based application has helped them to serve more than 140 million users per month. And also, they have been able to accelerate their release cycle 4 times. So they are able to put in production 4 more times the releases. But also, they have been able to reduce their cost of ownership by 25%. So this is a real-life example of a joint customer from Google and MongoDB who have been able basically to realize whatever we just said about speed of innovation, building scalable application, and offering a simplified operation. And these customers, when they are successful, what we want to do, it's really to help them build smart application. And we are working with MongoDB. And before we jump into the next topic, any other thing you want to add, Mira, about what we just said about speed of innovation, scalable application, and simplified operation?
No, I think everything you said is great. We've got a good question coming from YouTube, from Tim Manning, that I don't quite know the answer for, but perhaps you know if our reference architecture supports gRPC or protocol buffers.
Yeah, gRPC is supported. We can double check for the rest, so we can already respond live about gRPC.
Awesome. Thank you so much.
Okay. So now let's talk about smart application. This is one of my favorite topics, to be honest. So I am machine learning or engineer at Google as well. So one of the things that is interesting is that, as a developer, if you are a developer or you are an architect or you are a technical decision maker and you are attending this session, you are wondering, so what's new? So far, everything you said, maybe you know it, and oh, it was a refresher. So what are we offering you new today, right? So, and I think for some of you, this is the question you have on top of your mind. We think that building scalable application is good. Building, enabling speed of innovation good. Simplifying operations good. But building smart, intelligent application is much better. And how can we help you to do that? So basically, what we are trying to say is that at Google, we've been leveraging AI across all different products, whether this is about search, um, you know, whether this is using the translate is supported thanks to AI, whether this is Google Photo, Gmail, Chrome, all self-driving cars. So Google Cloud are, I could say, the challenges about using AI to create value. It's something we've been living for a decade, and what we want to do is to really help organizations leverage AI to achieve different challenges they have in industry. And there are AI opportunities in every industry where you are, if you are listening to us today. Whether you are in retail, you have challenges around using recommendation, forecasting. Whether you are in healthcare, whether you are in financial services, right? You want to do risk analysis, whether you are in media. So whatever industry you are, there is an AI opportunity. And at Google, before we speak about how we integrate with MongoDB, let me give you a very high-level overview of the offering. Number one, we have this infrastructure. And this infrastructure that we mentioned, it has one unique differentiator. It's TPU, Tensor Processing Units, which is much powerful and quite performant, for example, than legacy GPU. I invite you to Google that. On top of that, you have different foundational model. I think you have been all following the trend around generative AI. So Google came up with end-to-end generative AI. By the way, I think everyone knows by now that all the transformer architecture that is powering all the generative models that exist today has been invented by Google in 2017. So we are offering all kinds of large language models, whether this is about generating text, chat, generating code completion, code generation, whether you want to do image creation or whether you have video and music and so on. So we are offering quite a large set of services across that board. On top of that, we have an end-to-end Vertex AI solution. This is where basically we want also to meet you where you are. So whether you want to use API, like the demo we are going to do today. So basically, we have a different APIs. You don't have to train any data. You don't have to write any code. You can just integrate your application with the APIs. As a developer, you don't need to learn machine learning. You can also, if you have your data and you don't know how to train your models, we have AutoML that you can use. But if you want to write your own code and your own data, we have, of course, the custom machine learning model. And on top of that, if you want to use SQL, we have basically BigQuery machine learning. For developers, we have announced very recently Generative AI App Builder, which is basically very simplified applications that you can build, for example, a conversational application, for example, to integrate within your customer service, your website, to do things like conversational, to really speed up some services like customer services and so forth. And we have a set of basically business services like context content AI, document AI, discovery AI, and healthcare AI. So this is like the big picture, 1,000 feet overview of this. But today, our focus is how, without any expertise in AI, how can you start right now, build something with AI of Google? And this is how we do it. We have different APIs that you can right away integrate within the language of your preference, whether you are a Java developer, a Python developer, or whatever language you prefer. you can integrate, whether you want to integrate vision, you can integrate video intelligence, whether you want to integrate natural language processing. Today, we're going to present you natural language processing, natural language API. So you can integrate the application and you can be able to analyze sentiment, to analyze the language, to analyze basically what is going to be said. And we can chat with you about different use cases you can enable. So for example, comments on your website, to be able to analyze sentiment of the comments. There are so many applications. So today we're going to focus on this one, but you can see that we have a set of APIs that you can leverage to build your smart application. So really what we want to tell you today is that wherever you are, whatever, your expertise in AI, we are able to help you to build, to add intelligence within your application. And think about what you can do if you can integrate sentiment analysis into the application you build together on top of MongoDB. If you can add, for example, vision, you can add interact with your camera from your application. If you can add a translation, text to speech, you can talk with your application. So all this enabling the different capabilities. Think about the large language model. If you can integrate your MongoDB application with Palm 2, so you can basically leverage all the data. You can talk with MongoDB databases without writing any query. You can, instead of writing MongoDB query, you can just, chat with your content. This is kind of things we are going to unlock you. And today, actually, we're going to show you how we integrate natural language API with MongoDB. So really, I don't know if you want to add anything before we jump into the demo of how we integrate MongoDB with natural language processing through Cloud Run.
No, I think we're good. By the way, can you think of a question that we can ask the audience? Because we have some pretty nice swag to give away.
Yeah, I will think about it.
Not to put you on the spot or anything, but...
Yeah. I will think about it. So I think... I think for the audience, what can be interesting to think about is what are the things that was not possible that is now possible, combining MongoDB and Google Cloud natural language APIs. That's one question, and the other question is what is the expertise you need to build? Do you need machine learning expertise to build to build an application on MongoDB, or you don't need?
Nice. I like this question. So everyone who wants to participate can answer in the comments, and we will give away some t-shirts. I don't have the t-shirts myself, so I don't know how many of them we have, but I'm sure that we will give away t-shirts for the best answers here. All right. You can feel free to comment.
There is maybe a further, open question, like think about suggest some innovative, application you can build, leveraging any of the APIs that I have shown. Think about any creative idea you can bring, basically bringing together MongoDB and Google Cloud, AI, whether this is API or generative AI. Yeah, feel free to be creative and suggest some ideas.
Awesome. All right, let's jump into this demo today. So this is the application that we will be building, or we will build the database and the backend for it, and we will build the natural language API integration as well. So we have a bakery website, or a cakery. I don't know if that's even a word, but we have a list of cakes, and when I go to a specific cake, I can leave comments. So I can say this recipe was really good. I'll do it again, or something like that. And our goal today will be to take this comment over here, push it into the database, and then trigger a cloud function, an Atlas Cloud function, that will use the Google Cloud Natural Language API to analyze the sentiment of this comment. If some of you were here in the last episode of Cloud Connect, we did something very similar using generative AI, But today we will be using the traditional Google Cloud Natural Language API. Let's see how the application that we'll be building looks like. So we have this web application, it's built with Angular, and it uses GraphQL to communicate with our Atlas database. So we have this Atlas GraphQL API that we will also build together. When we push a comment in the website, it goes and it gets saved into our Atlas database. Now, whenever we insert a comment into the comments collection, a trigger detects this insert, and the trigger basically calls a function. Now, the function is a JavaScript function running serverlessly in Atlas, and the function takes the text that we wrote in the comment box and sends that to the Google Cloud Natural Language API. Now, this API analyzes the sentiment of the text. Was it positive? Was it negative? With a score from -1 to 1, with -1 being the most negative to 1 being the most positive, and returns that score. Now, when we get the score, we want to update the record in the database and save the sentiment as an additional field in our document. So we will have at the end our original comment together with a sentiment field that we obtained through the Natural Language API. Now we can go both ways here. We can go the easy way or we can go the hard way, and we can build everything from scratch. And if you know me, you know that we'll go the hard way. And it will be even harder because we have a brand new user interface in MongoDB Atlas. So I will be exploring this together with you because I was on a vacation last week and I haven't seen it. But this is MongoDB Atlas, and it's as though we're seeing it together for the first time because it's really fresh and updated look. We have our database deployments over here, and I have created one free cluster. So when you register for MongoDB Atlas and create a new project, you can deploy one free cluster. It will keep running for some time, then it will get paused and you can go and resume it, but it will never get deleted. It is free forever. You don't even need like a credit card or any payment information to register and create this free cluster. So if you want to explore MongoDB in a cloud environment, this is a really nice and cheap free way to do it. So we have our free cluster, and I'm going to go ahead and add some data in it. I will essentially add the data for our cakery. So we will add a bakery database. Let's start from here. So we have the database name. I will call this bakery, and the collection name. I will call this cakes. All right, let's see what else we have here. I can insert a JSON document. This is optional, but I'll still do it. So I have the document prepared over here. I think you might be able to see the banner showing the link to this tutorial, to this workshop that you can do yourself. It's available at Atlas Google Cloud Workshop. So I'm just copying this document from the written down instructions. All right, let's create this database. We are getting redirected now. And here on the left, we see that we have our bakery database and a cakes collection. If you're coming from a relational database world, a database is just a database, and a collection is something similar to a table, pretty much the same as a table. So we have a primary key. This is _ID. It's always the same name in MongoDB. If we don't insert a unique primary key, one will be created for us, and the type will be an object ID. And then we also have a bunch of other fields. We have some strings. We also have an array. So this is something different when you're using a document database. You can have nested arrays. You can even have nested documents. So we have currently one document. Let's insert one more. I'm gonna switch over here. So I can either add the fields one by one, or I can just add the JSON. I'm gonna grab it again and add it over here and insert it. And now we have two documents. Now I will add another collection called comments. And here in the comments, we will store the comments that people leave related to a cake recipe. So let's insert a document. I'm gonna go over here again, delete everything, and grab the comment. Now, again, here we have an underscore ID, and we also have a cake ID. Now, the cake ID, as you might guess, is just a reference to the cakes collection. So if we wanted, we could join data from this comments collection and data from the cakes collection so that we get all the comments relevant to this cake together with the cake. We also have a date. This is, again, a special type, and these are the milliseconds that have passed since 1970 or something like that. By the way, MongoDB uses a format called BSON, Binary Serializable Object Notation, to store documents. And we see that notation represented here as JSON. So we can read it easily. It's human readable, but in the database, it's saved in a binary format. So what we see here is not exactly the same thing that is stored in the database on disk. All right, we have all the data that we need. We'll be able to add more comments later on if we want to. And this is everything that we need for the database. The next thing I will do is create a backend. And to do that, I will use app services. I told you in the beginning that MongoDB Atlas is a lot more than MongoDB. It has a bunch of useful data services that we can use to develop applications. So I will go to the App Services tab. And here I can create sort of a low-code backend that we can use through our applications. We have a bunch of templates, but I will start from scratch. And it will take just a couple of steps to add our backend. We have a bunch of application guides. I will close them. We have even more guides if you need them, but I will pretend I know what I'm doing and just start doing it. So the first thing we need to configure is the data access rules. So who can do what with our data? We have our two collections. I will select cakes. And I will use a preset for data access. I will say read all. Everyone can read all documents. And only that. No one can edit the documents. Again, this is our backend. Of course, the database administrator, if you log in or connect directly to the database, you can still edit the collection. But this is for the backend rules. And for comments, we will use another preset, read and write all. Now, this is not the best preset you can use. Usually you would want people to be able to only update their own comments, but it's pretty simple and we will use it for our demo. But if you wanted, you could also add field-specific data access rules or even filter people coming in based on their ID. So let's deploy that draft. Let's deploy our backend here. And the next thing that I need to do is define a schema. Now, I will be creating a GraphQL API, and GraphQL is strongly typed. It has a strong contract between the client and the server, and we need to define a schema over here. Again, here we are defining a schema for the backend and not a schema on our database. So even though we have a schema here, if we go and update the database directly, we can do that, and we can overwrite the schema rules that we define over here. Let's go to define schema for cakes, and I will actually generate the schema using a sample of the existing documents inside this collection. So you can see that Atlas managed to recognize all the fields that we have and also their types. So this is quite convenient. It saves me some time. I will save this draft over here. We'll review and deploy it just in case. As you can see here, this is all just a JSON file, so you can put it under source control and actually work on it even without the user interface if you want it. And I will do the same thing for the comments collection. Define a schema. You can also manually define your schema if you want to suffer. I don't want to suffer right now, so I will just generate the schema. I will save this draft. And there is one important thing that I need to do here. I need to connect the cake ID from comments to the cakes collection. So I will create a new relationship, and I will relate cake ID to bakery cakes underscore ID. So this foreign key is now connected to the primary key in the other collection. Let's save the draft again. Redeploy. You can disable the drafts, by the way, and you don't have to redeploy all the time or every single time you make a change, but I'm kind of paranoid, so I just redeploy every time. All right, these are the only two things that we needed to do to enable our GraphQL API. Now, if I go over here under build, I can see GraphQL, and this is our API that is ready to use. This is a graphical editor that we can use to send requests to the API. I'll just delete everything over here and let you look at that for a couple of seconds until I go and copy my GraphQL query. Right. So we're querying cakes and we're getting the name and the description. Let's see if that works. And it works. It had worked the first 100 times I tried it, and thankfully it works now. We can, of course, do more complicated queries using GraphQL. So I can get the comments that have cake ID that matches this string over here. And then we can also resolve the cake document and get the name for the cake. So if I get chocolate cake, I can get all the comments for this chocolate cake. And this is something that I'm using in the front end of the application. So we have our backend, we have our database. What is left is deploying the application. We're not going to build the front end from scratch, but if you wanted to, we have all that hosted on GitHub. So you can take a look at how the whole application is built, and you can just basically clone it and reuse it for your own projects. All right, let's go over to Google Cloud and deploy this application. Now for the deployment, I will be using Cloud Run. Delphin, would you like to share something about Cloud Run before I proceed? I hope that you can still hear me, by the way, or I'm doing this demo too.
So yeah, Cloud Run is very interesting because it combines the power of Kubernetes with basically the benefits of a function. So like you will show, you don't have to manage the infrastructure. You can just choose, you can select a region. You can select the service, upload your code, build your code from your Docker file, and then you can just deploy. And your application is going to be live, and you will be showing you're going to have like a URL that is going to be like the service, the service to access the service. So the benefits for the audience is that you have a service that can scale from like 1 to 1,000 of Kubernetes containers, and just it can scale, and you only pay what you use. So this is quite interesting. Yeah, that's all.
It's awesome. Yeah, I love Cloud Run, and it's like super easy to use. You just need a Docker file, and you can deploy your service. And I will show you how to use it right now. So the first thing I need to check here is if I have the right project set. So gcloud config get project, and this should show me MTV Smart Apps. Awesome. If I didn't have it, I could use the set command to set it. The next thing that I need to do is enable a couple of APIs. So I need to enable first the Cloud Run API. I need to authorize the console and fix my typo over here.
Yeah, the other thing is that everything you can do here, and everything you can do on CLI, you can also do this on the GUI in the service. this helps you make sure that you only have activated service that you need.
Yes, that's true. So you can basically search for these APIs and enable them using the UI, or you can just run a command and enable them. All right, so I have the two APIs. Just to make sure I have everything I need, I will list the enabled services. And you see here that by default, we have a bunch of services. This is a brand new project, and we have a bunch of enabled services. So here we also have the Cloud Natural Language API that I just enabled before I started screen sharing, and that we will need. We have Cloud Run Admin API, and if I scroll a little bit, we will also see Cloud Build. We need Cloud Build to build the container image that we will deploy for our service. And just to show that there is also a very nice graphical user interface, I will go back here, close the console, and navigate to Cloud Shell editor. So the Cloud Shell editor, the graphical user interface that we will see is very similar to VS Code because it uses the open source components that Visual Studio Code uses, like the Monaco editor and the plugin system. And you might have noticed that a bunch of other online services like virtual web IDEs also use something that looks a lot like Visual Studio Code. So if I go to my extensions over here, I should be able to see Cloud Code. And if I remove development sessions and Cloud Run, we can now go over here and deploy a new service. And I think I need to reload because I don't have my workspace opened. Let's reload this. While it's loading, I will just go quickly back to the terminal. Oh, it's actually, the session is transferred, so I can't go back here. Let's close this to make sure we don't scare the Cloud Shell. I still have no folders. All right, I'll open this guy over here. Google Cloud MongoDB Atlas workshop. Again, all of that is on GitHub and you can play with it. Let's open the environment production file because this is where I need to add all of my secrets. So I need the app ID for the backend that I created, the GraphQL user interface URI, and the API key. Let's go back to Atlas and grab all that. So the app ID is located over here. You don't have to remember that. You'll have the recording later and you can use the documentation. The GraphQL endpoint is over here. And an API key I will generate right now. So let's go to authentication. You see we have a bunch of different authentication providers that you can use. I will just enable API keys because it's kind of easy to show that, but it might not be the best choice for a web application, to be fair. Let's deploy it and create an API key. And I'm not afraid of exposing that because basically everyone who can open my application on the internet can open the API key and see it in the code. So you don't need to hide that. All right, let's go back to Cloud Code, minimize these thingies and create a new Cloud Run deployment. This will take a couple of minutes to load, but what we will do basically from this screen over here is build a container image, upload that to Google Cloud and deploy it at the same time. If you were to do that through the console, you would have to run a couple of different commands to do it. So we will create a new service. Let's name it something more meaningful like bakery. We will use Cloud Run fully managed. We can select a region that is closer to us. Like my database is deployed in Belgium, so I will deploy the web app in Belgium as well to minimize the latency. I will allow unauthenticated invocations because it's a public website. And then finally, we will select the Docker builder, and we will select the Docker file that I have over here in my application. So this is the Docker file that we are selecting. I will hit deploy, and it will take from 3 to 4 business days to deploy that because there is a lot of NPM modules to be installed by Angular.
Yeah. So what is interesting in what you guys have just seen is that it's how fast and how quick it is to deploy Cloud Run. And that's it. You name the service, you choose the Docker file, and that's it. This is really something that is very quick, and this is like easy to build. Even if you are not deploying on this, you are using the API. You can just smoothly deploy this very quickly with just almost one click.
Indeed. And as I promised you, the npm install takes a while, but now it's finished and everything else will be like super fast. Now we're running the npm run build command, which is building our Angular web application. And finally, we will move all that to a container, and that container will be deployed on Cloud Run. And again, the biggest benefit of Cloud Run is the elastic scalability. It scales by default to 1,000 container image instances. You can, of course, modify that number, and you can restrict to scale up to 10 or even 5 if you want. And something that is also interesting is that if you're using Google Cloud Functions version 2, the generation 2, they also run on Cloud Run. So you're essentially deploying a Cloud Run service every time you deploy a cloud function in Google Cloud. So they have the same benefits of elastic scalability and scaling down as well.
Yeah, and in the application that we are deploying, you will see that you will be able to do this application integrates with natural language NLP, natural language processing. But what we want to also to think for you to think is that this can be any other API that we have presented before. It's important, like this is just to show you how quick and easy it is, but it can be it can be text to email, text to voice to text, or it can be integrating with a generative AI thing where you type something and a generative AI LLM is doing something. So this shows you how it's going to be easy and quite nice to run different use cases that you have in mind for your own organization, right?
Indeed. And while we are waiting for this to get deployed, let's go back to the architecture of the app. So far we have created quite a lot. We have our database, the GraphQL API, and we are now deploying the application to Cloud Run. Next, we will create a couple of functions that can analyze the sentiment by connecting to the Cloud Natural Language API. And we will connect these functions to a trigger. The trigger will watch for inserts in the comments collection. And basically every time we insert a document into the comments collection, we will run this function that will analyze the sentiment, and the sentiment will be stored back into our database. And we have deployment completed successfully. Let's open it. This is the time of the moment of truth. Is that the way you say it? Let's see if it works. Can I get some drum roll? Yeah, okay, it works. So we have our cake and we have our comments. Again, our goal will be to analyze the sentiment of the comments that we leave. So how do we do that? First, you need to enable the Cloud Natural Language API. language API. So basically you search it here, you go to the API page, you click enable if you haven't already. Let's verify that we have it. It is enabled already. If you haven't, you have to just enable it. And then you need to generate a Google Cloud API key. I have done that already, and this is something that I don't want to share with you. It's a bit more sensitive than the Atlas backend. So I will just go over to Atlas and add it here as a secret. So I have values, and I will add my secret as a secret. So we have GCP API key, I select a secret, and now I will hope that this stays hidden. It's hidden, amazing. We didn't leak any important information today. Now I also need to connect another value that has the same name. It doesn't have to the same name, but it could. And I will link that to my secret. Now, the point of doing that is that I can't just access a secret from my backend, from my functions, or anywhere else. I need to be able to I can only access values, and I can connect this value to a secret and access it. It's a bit weird architectural decision, but we will live with it. I will add one more value to kind of repeat the exercise, and I will add the sentiment analysis URL. This is just a value with some content, and I will copy this from our tutorial. Now this is the URL, the endpoint that they need to hit to analyze the sentiment of the text that they need to analyze. Let's save that. We have 3 values. I will deploy that just in case. And now I will add a couple of serverless functions here in Atlas that will analyze the sentiment. All right, so the first function will be called analyze comment sentiment. I need only system authentication, and then I can switch over to the editor. This is JavaScript, but you don't need to know JavaScript to follow along because I'll just copy the code. But what we do here is we extract the URL, the API key from the values, and then we send an HTTP post request. We send the content of the comment as part of the body. The comment is passed as an argument to this function. That's everything we need. And finally, we just return the response from the API. Let's save this, and I will add one more function. Again, because repetition is good. We go to functions, create new function. I will call that, get comment and analyze it. And now this function is a little bit more specific because it receives a change event. Now this change event will be passed in by the trigger. So every time there is a change in an insert, we'll receive the change event. We'll extract the comment document from it, and then we will execute the other function, analyze comment sentiment. This is just like a separation of concerns by the two functions. We get the sentiment. There should be a try catch somewhere over here, or some sort of error handling, but we don't have it right now. And then when we have the sentiment, we just get the comments collection, and we update the comment document. We set the sentiment field inside this comment document. And that's everything we need to do to get the sentiment and save it into our database. There's one more thing that is missing in our configuration. Can someone guess what it is?
Triggers?
Triggers, that's right. So let's go over here. Underneath functions, we have triggers, and I will add a brand new trigger called get comment and analyze sentiment. I'm not very creative with names, so this is the name for now. And now I need to connect to the trigger event, right? So we are gonna connect to the comments collection, and this trigger will watch for inserts. I also want to receive the full document that is being inserted. And finally, I will connect this trigger to the get comment and analyze it function. that we just created. Let's save this, review draft and deploy, and let's hope that it works. I will open the logs just to show you that we have logs, and just in case I need to debug something now. And let's go back to our baker website. So the thing here is saying that this recipe was really good. The cake was all right. I might do it again. Something like that. So we have, that's good to know. So we have the comment added. Let's go to the logs and see what happened here. So we have our trigger that called get comment and analyze sentiment, and something might have happened. So let's go back to our database and see what is inside this document. At least we know that the trigger actually executed the function and something happens. We don't know the result yet. So let's go to the cluster, view deployment, and then to the collections, and then finally to the comments. And the moment of truth. Let's see what we have here. We have Delphin's comment, and we have a sentiment field. Now this is the field that we needed. We have the document sentiment, which has a very large magnitude. So some of the sentences were positive, some weren't that positive. And we have an overall positivity score of 0.6. We also have an analysis for each of the sentences. So for this sentence, this recipe was really good. We have a very high sentiment score, positivity score. The cake was all right, is scored as neutral. And I might do it again. It should be, yeah, this is quite positive. I would say it's not that positive, but that's what the AI API says. So we will assume that it's positive. And again, the overall score is 0.6. And as Delphin said, you can use the same integration pattern for all of the other cool machine learning APIs that Google Cloud offers. It's really flexible and it's really, really easy to use. And I will stop screen sharing. We can go back here and wrap this up. And the session is recorded and you can access it on YouTube
awesome.
later.
I think you really, what is great is that this demo just works perfectly and built from scratch in just 30 minutes. You can see how easy it is, right? And go ahead and have a look. We have different resources. Have a look, and you have the access to the GitHub repo. So access to this and play with it. We would like to hear your feedback. Feel free to connect with us on LinkedIn and follow us. We have more to come in the future. Thank you very much, Mira, for hosting us.
It was really, really good. Are there any questions that we need to answer? I'm asking our moderator here. By the way, you can try MongoDB Atlas for free, and you can also sign up for the free trial that Google Cloud offers. It is quite generous.
Yeah. So for Google, there is a question. Google Cloud, you have the possibility to run a free tier access. So for each Google Gmail address, you can have an account. And you can basically deploy. You have $300 free tier, which more or less can help you deploy almost any kind of service at certain limit, of course. But it's very generous offering for you to get started. And we have different opportunities and different also offering to train and to get certified on Google Cloud. So feel free to search the website.
All right, we have a question. Okay. What should be the backup policy? You can have backups in MongoDB Atlas for the paid tiers, not for the free cluster, but from the lowest paying tier up to the highest, you can have backups scheduled at different times a day, a different frequency, as frequent as you want, basically.
Okay.
And for Cloud Run, it's also really interesting. For backups, there is something called gradual rollout. So every time you deploy a service, you basically deploy a new version, and you can roll out some part of the traffic to the new version and keep the rest of the traffic at the old version. And this also allows you to return all the traffic, revert versions to I got mixed up here, but you can revert all the traffic by redirecting it to another version. It's not quite a backup, but it's cool for rolling out gradually and for reverting changes.
Right. Yeah. So Mira, so that really, wrapping up and starting from where we started, hopefully we have been able to show you, how together with MongoDB and Google Cloud, fit into building those amazing applications, right? How we help, scaling application, speed innovation, and also integrate the intelligence within your application. So hopefully this gives you some idea about what you can do. There is much more. We're really continuing to work together with MongoDB around enabling intelligence, especially you're going to see much more coming with generative AI. So really thanks for joining us, and we hope you had a good time and you enjoyed watching this demo as well. Thank you very much.
Thanks, everyone. Thank you.